because it simply means the hematopoietic stem cells in this case cannot become double positive T cells, but this doesn't tell you where the block is, right? It could be anywhere.
So we observed a reduced number of the T cells from, I think I harvested the cell, smaller number of cells. But I think in the different experiment I could observe the double negative cells, but maybe probably double negative 3 to double negative 4, maybe. Not a double negative 4 to double positive stages, probably. But I don't remember exactly. So how about the positive and negative selection in the thymus? So I use the HYTCR transgenic mice. As all of you know, the female mice, you can measure the positive selection. So although the frequency of CD8 single positive T cell is reduced at the same ages, but these CD8 single positive T cells in double knockout mice possess the HY specific TCR. And this reduction is gradually recovered with age. So we judged, we thought that positive selection is not impaired, rather the positive selection is just delayed in the absence of star-operated calcium entry. And so in non-transgenic mice, we evaluate the TCR V beta and alpha repertoires. And so TCR V beta and V alpha repertoires were comparable between the control and double knockout mice. So, and overall, positive selection is not altered in the absence of star-operated calcium entry. So how about negative selection? So we observed that the negative selection was slightly impaired using the HY transgenic mice. Here you can see. And so we carried out another negative selection models, super antigen deletion models. So it is well known that the CD24 high immature TCR V beta 8 positive single positive thymocytes are sensitive to the staphylococcal enterotoxin B. So we injected staphylococcal enterotoxin B into mice. And then we observed the increase this sensitive population compared with the control populations. So this data also supports the negative selection is mildly impaired in the absence of star-operated calcium entry. In addition, on the BALB/C background, the STIM1 singly knockout mice shows the impaired endogenous antigen-mediated negative selection. So V beta 11 and V beta 11 is sensitive to the superantigen MTV, VS. So the STIM1 deficient mice show the increased number of these sensitive T cells, thymocytes. So this data also supports the negative selection is mildly affected in the absence of star-operated calcium entry. And due to this impaired negative selection, this BALB/C background STIM1 knockout mice shows hepatosplenomegaly. So let me summarize the T cell development of conventional T cells. So unexpectedly, the STIM-dependent star-operated calcium entry is dispensable for the positive selection, suggesting that STIM-independent star-operated calcium entry or non-star-operated calcium entry can compensate for the absence of star-operated calcium entry. And as to negative selection, the star-operated calcium entry affects the negative selection partly. besides the positive and negative selections, it has been reported that there is another process, selection process, through which the self-reactive thymocyte mature into the unconventional T cells, like CD4 Treg cell, FOXP Treg cells, or INK T cells, or CD8 alpha alpha TCR alpha beta IEL cells. So this selection is now called as agonist selections. So agonist selected T cells is thought to have regulatory roles in vivo. So based on a partial defect of negative selection, we speculate that the stop-related calcium entry is selectively affect the agonist selection and the development of the agonist selected T cells. And this speculation was true.